It's really exciting to see how much has been accomplished in the Presidio since, in the last 20 years. It's truly remarkable. And everyone who's had a hand in it deserves incredible congratulations for being able to, turn it into what it has become. But what I'm going to do today is very different. So I hope you're ready for this, because I'm going to bring you an East Coast sensibility. And I'm going to talk about cities that are not as financially or geographically fortunate as San Francisco. San Francisco is really unusual. To have a place like the Presidio, more or less in the middle of the city, I mean, that is just amazing. Remnant natural populations, 20 rare and endangered species, I mean, that's extraordinary. But not every place is like San Francisco. So I'm going to talk about, really today, what I call, it's urban ecology, but it's really urban nature. I'm very familiar with all of the issues around the stewardships of parks. I've worked at the Arnold Arboretum in Boston. That's 250 acres, operated by Harvard University for 35 years. So those are my credentials in terms of the unleashed dog problem. I just want to put that on the table, that I have had real experience in that regard. But, I'm going to talk about this in many ways. I see this as that big question mark that Michael just put up there, this other kind of nature. There is something that is happening, some of which we control, but a lot of which we do not control. And what does that nature look like? And the reason this is important is because it's about the future. That's really where I come from. So I teach at the Harvard Graduate School of Design. And, for me, it's all about the future. I want my students to be able to think about, what is the world going to look like 20 years from now? How do you visualize it? And the answers are actually right out there. It's just a question of learning how to read that environment. So this little picture here I like to start with. This is from Detroit. Those of you who haven't been to Detroit, from a sociological point of view, it's a totally depressing situation. There's no work. The population is shrinking. It's one of the places in the country where land has lost its value. It's hard in San Francisco to imagine land having no value, but it's absolutely true. There's way more land than anybody knows what to do with. But if you're like me, you're a botanist and you're interested in vegetation, particularly spontaneous urban vegetation, we like to call it, Detroit is a fabulous place because you get to see how nature interacts with the urban environment on its own terms, not mediated by maintenance and design considerations. And this is urban ecology. This is unadorned, unadulterated urban ecology, the topic of my talk today. I published a book about 5 years ago called Wild Urban Plants of the Northeast. Covers 222 species, but if you look at the breakdown in terms of nativity, where these plants come from, about a third of them are native to Eastern North America, almost half from Europe and Central Asia, 10 to 12% from Eastern Asia, and 7% are native to both Eurasia and North America. The basic point is that the vegetation of most cities is really as cosmopolitan as its human population. And this is a graph. I just discovered this. It's really interesting, but there's a famous botanical text, Gray's Manual of Botany for the Flora of the Northeastern United States. And you can see there the early edition in 1856, about 10% of the flora that had been described was non-native to the Northeast. By 1890, that number had gone up to 14.6%. By 1908, 16.3%. 1950, almost 20%. And now in the 90s, depending on which state you're in, it's anywhere between 24 and 35% of the total flora is not native to the Northeast. Now, and this number is not going down, okay? This is a trend, okay? It's just like, increasing temperatures. This is what is happening. You can create little islands where you manage to eradicate non-native species, but the bigger picture, of course, is that our ecology is really becoming as globalized as our economy now is. And you can see this. This is just a chart that I pulled off the internet for the city of Boston, looking at the composition, or the racial composition of the city over time. And these types of changes, this is actually succession over time, and just the way that the human population changes and develops in response to socioeconomic conditions, the biological aspects are also changing. What's interesting, though, when you look at a chart like this that's broken down by race, what you realize, if you haven't been to Boston, there's a lot of students there. So, where's the line for students that sort of crosses these ethnic, categories? And that's what I would call a functional categorization. So, when you start, depending on how you want to break up your statistics, that really influences how you sort of view the world in which you live. But the basic point here, of course, is obvious to everyone. Another really important point is the definition of urban. A lot of blood has been spilled over this question. The traditional definition would base that on the density of the human population. So here for the Northeast, 500 people per square mile. So you realize that, urban, when we say urbanization, we're not talking about sidewalk cracks and parking lots. We're talking about a significant portion of the land area is fully urbanized, certainly in the Northeast. But in the West, of course, urbanization is just as rampant. I love this picture of Los Angeles taken as you coming into LAX, And so you can talk about what used to grow here, but the concept that there's a native vegetation to these current conditions, personally, I find that something of an absurdity. I hate to be so harsh, but you can see the LA River there, sort of off to the right, and I'm happy to say that now there's water in the LA River pretty much year round, which is great, it's a triumph, but that's all effluent from sewage waste treatment plants is now going into the LA River. So they're bringing back the ecology of the LA River, but it's through the reprocessing of wastewater. So yes, it is the LA River, but it's not the way the LA River once was. Cities have very characteristic environmental characters, not the least of which is known as the urban heat island effect. And you can see on the vertical axis, that would be degrees difference between an urban area and an adjacent non-urban area, and then along the horizontal axis you have the population of the city, and you can see as the city gets bigger that the difference in temperature, and this is on a warm summer night, between an urban and a non-urbanized area can be as much as 12 degrees centigrade, so that's almost 21 degrees Fahrenheit. Not that San Francisco is warmer than Berkeley or anywhere in the Central Valley, but San Francisco is definitely an exception. So cities are really much warmer in general than the surrounding non-urbanized areas, which makes them extremely important that we should be focusing resources on studying them because they provide a very clear image of climate change, what is going to happen in the future, because the cities, because of this urban heat island effect, have already warmed up to the extent that is projected for non-urban areas in the same latitude. And I apologize for this slide. It's a little bit complicated because it's Boston, but there's an Interstate Highway 95 that rings the city of Boston, and you can see 0 represents downtown Boston and 100 kilometers represents the Harvard Forest in Petersham, Massachusetts. As you drive from downtown Boston out to the Harvard Forest, due west, or a little bit to the northwest, you find that when you're inside the 95 Beltway, this is based on square kilometers along a transect, that all of the sample points inside 95 had at least 25% impervious surface. Once you cross that 95 Beltway, with one exception, all of the square kilometers had less than 25% impervious surface. That's roadways, buildings, etc. The reason this is significant, it means that we now have a definition of urban that is not based on human population. When you have 25% impervious surface, you are an urbanized environment from the point of view of the vegetation and the biology. because we know that creating roads fragments the environment, compacts the soil, and interrupts the hydrology. So when I talk about urbanization, it's not just about cities, it also includes many of our suburbs. They're just sort of on a trajectory to become cities, and many of them, there's really not that big a difference between urban and suburban environments. Of course, I like to analogize urbanization to glaciation and heavy equipment that is used to clear the land, leaves in its wake compacted glacial till. This is really just primary succession. This is what you find after the glaciers recede, and basically vegetation has to come back from nothing. This picture is, again, I apologize, it's Boston, not San Francisco, but you can see this is the fill map of Boston. Going back, Boston was founded in the 1600s, and the red represents the original land mass of Boston. The beige was filled in prior to 1890, and the gray represents filled land after 1890. And roughly 16%, 1/6 of the land mass of the city of Boston is built on fill. So I ask you, what is the native vegetation of filled soil? In the case of Boston, that whole area, the famous Boston Public Garden and Commonwealth Avenue, built in the 1840s through the 1870s, all built on fill of the Charles River Basin. So, there's no going back when you start talking about filled landscapes. And of course, it's not a surprise to anyone if you look at the FEMA maps for flood threats that were issued in 2013, the only areas that are under extreme threat of flooding with sea level rise are exactly those areas that were created from fill. San Francisco, it's not quite as extreme as Boston, but the entire eastern edge of San Francisco, which is where there's a lot of, obviously, drainage, and you can see quite a nice little chunk of the Presidio and Crissy Field are built on fill. And of course, not only do you have to worry about rising sea levels here in San Francisco, but you also have to worry about earthquake damage. So these are all these soils that, with a big earthquake, they'll flux and slip. So, again, there's no point in talking about native vegetation in the same breath that you're talking about filled landscape. And we all know that filling is a messy process. It's not a pretty process, but it's how we create new land, and it's been part of our urban heritage for a very long time. And I want to just take a time, because I'm going to talk a lot in this talk about soils, because if you actually want to understand the ecology of urban areas and what are the drivers of ecological change, it always starts with the soil. And there's a huge difference between native soils and filled soils. And, these are the basic characteristics. I don't have too much time, so I won't run through them, but you can see that. And soil is biological. It's a layered structure with tons of biological activity. And, to contrast that, filled soil have a very different set of characteristics and support a very different type of vegetation. Basically, you can't create a native ecosystem. Really, it's very hard to do that without native soils. You can create something that might look like a native ecosystem, but at its basic functioning core, it is not a native ecosystem. So on these fill soils, the possibilities, the potentialities are very, very different. In the East, we salt our roads religiously. And, nobody gives much thought to the implications of spreading this road salt down, how it affects the soils in terms of increasing its compaction, changing its pH, and decreasing the availability of nutrients. Nobody wants to compromise public safety for the sake of a few plants. And so, but the plants know what's going on. This is what's really interesting, and they track the application of road salt very, very carefully. These are all in the East Coast. Many of the plants that are common come from areas with high pH soils. That's, of course, sodium chloride. Sodium and calcium are chemically related, and so you put sodium chloride down, and basically you raise the pH, and plants are totally aware of that. And one of my favorite plants, Ailanthus, which I guess I haven't seen too much of it in San Francisco, but if you go into the foothills of the Sierras, you'll see plenty of it, from China, is another one of these species that lines all of the interstate highways in the east. And it's basically tracking soil compaction and road salt. But what's really interesting is that some native species that in earlier times were confined just to coastal areas, like the seaside goldenrod and this Bacchara species, groundsel bush, have actually over the past 30 years migrated inland along the interstate highway corridors, tracking the application of road salt. So, this is the thing. It's not all just native or non-native, one or the other. With this urban nature is a combination of the two. It's really cosmopolitan. It's not an all or nothing thing. There is middle ground, and both of the earlier speakers talked about this middle ground, and it's really important. I think that, we begin to think about what is this new type of sort of urban ecology? What does it look like? And inevitably, in my experience, it's always a combination of both native and non-native species. I love to show this picture. Now, if you're not from the East Coast, you probably don't recognize this, but this is the Vince Lombardi exit on the New Jersey Turnpike. Okay, if you've ever driven down there, it's a sea of Phragmites. And, the restorationists hate this plant. This is a European ecotype of this invasive species that has displaced, the cordgrass, and they would love to bring this cordgrass back. And so, I say, if you actually want to restore the New Jersey meadowlands, actually, it's not that difficult. You just remove the New Jersey Turnpike and you restore the tidal flow, because Phragmites doesn't like high salinity water, and the cordgrass will come back. In the meantime, there's over 500 landfills in this area that are leaking nitrogen and phosphorus, and the Phragmites is actually cleaning the site up. So there's two ways of looking at this situation, and it's really important to think about, the implications of that. And then you start looking at Phragmites. Here it is on the left, that's Detroit. There was a little clump of it along that fence line, and then the rhizomes went under the sidewalk and popped up in the gutter there. And then this is the Fresh Kills landfill, where there was a little patch, water collected there. The Phragmites got established. And look at those rhizomes, 20 feet long, going across that concrete bunker, looking for a little patch of soil. This is an amazingly tough plant. And in fact, it is actually performing valuable services on Fresh Kills landfill. There's no native vegetation on Fresh Kills landfill. It's a landfill. The other thing to think about, the vegetation that grows in urban environments tend to come from areas, habitats that are similar to those found in urban conditions. So that I would call that pre-adapted. So there's the Ailanthus on the Great Wall of China, and there it is on the Great Wall opposite the Arnold Arboretum. And they're both limestone-based. And, Paulownia tomentosa, the princess tree, what is a decaying brick building but a limestone cliff? That's all it is from the perspective of a plant. And, European ecologists who have really studied this issue in great detail have found that the majority of the vegetation that grows spontaneously in urban areas, they prefer habitats that are relatively fertile, that would be high nitrogen, dry, sunny, and alkaline. That's the profile of your typical plant adapted to the urban environment. And if you look at what are the pre-adaptations for urban plants that makes them suited to grow in the urban environment, limestone. They love limestone. Any masonry, of course, is limestone-based, and in the presence of acid precipitation, that limestone leaches out and creates little pockets of limestone soil. Floodplain trees typically do very well as urban street trees because they're used to growing on compacted soils with low oxygen tensions, which are exactly the conditions you find on city streets. Taprooted species from rocky outcrops do very well in sidewalk cracks, because there's only a little bit of room available, and the more you can sort of penetrate that crack and then spread it as you age and develop, that enables you to survive. Disturbance-adapted trees and shrubs that can sprout back, they're, of course, adapted to our maintenance crews with their weed whackers, all right? The more you hack them back, the more they sprout back. Not every tree has that capability. Obviously, pines can't do that. But those that can do that, they're pre-adapted to surviving maintenance regimes. Winter annuals that germinate in the fall and flower in the spring, they're some of the big winners in climate change, because what's happening in the East Coast is, as winters get warmer, the fall is more protracted and the spring comes earlier, and plants that are right to deal with those two seasons, they are big winners. And that is, I see that all around San Francisco Bay, of course, as winter becomes shorter and drier. These winter annuals are really taking advantage of it. Day length insensitive species that leaf out early in the spring and hold their leaves longer in the fall, they're better adapted, essentially, to take advantage of what's happening to our climate as a result of, pumping so much CO2 into it. And of course, heat-loving plants flourish in densely urbanized heat islands. And now I'm going to go very quickly, but I have my own taxonomy of urban environments, a little bit like Michael. You have remnant natural urban landscapes, which you find a number of them here in the Presidio. You have managed or functional urban landscapes. But what I'm going to talk about for the rest of my time are what I call the ruderal urban landscapes. I love the word ruderal. It comes from the Latin rudis, which means broken stone. And these are plants that grow on rubble. Okay, so urban ecology is really based on this whole concept of plants that go on rubble. It was born in Berlin, Germany, following the end of World War II, when that city was reduced to rubble, and the ecologists couldn't leave the city. So they studied what was at hand, and they studied the plants that colonized these piles of rubble. And that's the birth of modern urban ecology. And it looks at the city as a unique habitat. It's got its own ecology, and it's worth studying that ecology. And not for what it used to be, but for what it is and what it can become in the future. And how much land in any given city consists of this type of ruderal vegetation. So this is my students and I did this for the city of Somerville. The yellow lines represent railroad tracks, surface railroad tracks. So for the city of Somerville, adjacent to Cambridge, roughly 10% of the land area is unmanaged by anyone and dominated by spontaneous vegetation. For the city of Detroit, that figure is an astounding 40% of the land area is essentially abandoned. The green that's San Francisco, and the red is the city of Boston. So, when you start talking about Detroit and you look at the scale of the problem that they face, it becomes very, very daunting. And what does Detroit look like? If you haven't been there, there's maybe 1 in 10 houses standing where it used to be a full city block, and the orchard grass has taken over. You feel like you're in the middle of the countryside. Of course, the vegetation is taking over obviously the window is broken. The water is puddled there on that second floor, and the willows have found themselves a little mini wetland up there. And my favorite, of course, is this loading dock wetland. Obviously, the drain has been plugged up. The water isn't draining. The Phragmites has come in there. There were red-winged blackbirds there. I didn't see any frogs, but I wouldn't be surprised if they essentially moved in. But this process of nature coming back to urban areas on its own terms, I think, is really an interesting process. It's an evolutionary process, and it's something we need to actually pay some attention to. In the East, we talk about old field succession, the vegetation that came back following the abandonment of agriculture. Well, what we have now that is exactly analogous is post-industrial succession. And we need to put that same level of academic intensity on this question of what is the natural process of rebuilding ecology in an intensely urban environment, as we did studying ecology coming back following agriculture. And I really apologize for this slide, because I hate slides that look like this. this, but I don't have a chart, but it shows that, if native forests are converted to cities or to suburbs and suburbs are converted to cities, they don't go back to being native ecosystems. They become what are called novel or emergent ecosystems. There's no going back. Once you've achieved this level of hardness, okay, as opposed to a soft land transformation, then that limits what you can become in the future. And it's very important to realize that some of these changes are really permanent. And so when you're talking about urban environments, it's really important to understand the nature of this disturbance. So there's long-term, large-scale environmental disturbances such as nitrogen deposition, climate change, urbanization, and invasive species are chronic stress factors that permanently alter ecological conditions. These are non-reversible, basically. You can clear out an area, get rid of invasive species in a small little area, but if you look at a larger landscape scale, those invasive species aren't going anywhere. And, basically when you are removing invasive species, you're basically gardening. You're deciding, the thing about gardening is you get to decide who lives and who dies. That's why gardening is such an attractive enterprise, is the illusion of control. And so, you're just playing God. Okay, I like this plant, I don't like this plant. And you can accomplish ecological aims, you can restore native ecosystems, but the process of deciding and weeding, as you know, they never end. It's not like you reach the state of nirvana and everything is all done and you don't have to worry about it again. It actually never ends. And that's what I mean when I call a lot of restoration is actually ecology dressed up to look like, or horticulture dressed up to look like ecology, because the actual processes are very horticultural. Short-term episodic disturbances, floods, wildfire, those are very different, and environments are very good at recovering from those, and the recovery is usually back to the original state. But the basic bottom line is that native ecosystems are resilient in the face of episodic disturbance and not particularly resilient when it comes to chronic long-term stress factors. That's where these native ecosystems come into it. And just to sort of review, the interacting forces, urbanization, climate change, and globalization represent chronic stress factors. Water, air, ground pollution impact soil chemistry, which impacts microbial activity, which impacts nutrient cycling and vegetation patterns. And of course, habitat fragmentation or urban sprawl creates sunny edges dominated by fast-growing, disturbance-adapted species. So these are the drivers of ecology in the urban environment. And I'm going to end now with a little case study. This is at the Arnold Arboretum. It's called Bussybrook Meadow. It's a 24-acre site that's derelict. It's surrounded by infrastructure and became part of the Arnold Arboretum in 1996, and when I was in charge of the living collections. And the question is, what are we going to do with it? 250 acres of the Arboretum is impeccably manicured with a fabulous collection of trees and shrubs from all over the world, and all of a sudden we inherit this derelict site. And we don't have a big budget to actually, turn it into something that looks like the Arboretum. And the question becomes, what are we going to do with it? So in 2011, I was instrumental in essentially making the decision that we were going to use this site as a place for research on urban ecology. Because, in a city like Boston, which is very prosperous, like San Francisco, nobody ever leaves anything alone. Everything is constantly being turned over. If you want to see urban vegetation 20 or 30 years later, you have to go to Detroit. We don't have that in Boston. So the question of what happens to these urban landscapes over time is really interesting. And there's not a lot of places where you can actually study it. And that's a really important ecological question. It's a very beautiful site, a long history of dumping and filling. And there's a road that goes along one side of it that was built in 1670. So we're talking 300 years of abuse, is what I like to say, on the site. It was a huge wetland, of course, and over 50% of that wetland has been filled over those 350 years, including an 8-foot diameter sewer pipe built in 1901 that nobody even knew, everybody forgot was there. But when it overflowed, of course, everybody remembered it was there. 6-acre landfill, again, built illegally when it was the city of Boston property in the 1950s, and there it is, construction rubble, a mountain of it, and we just inherited that when the property became ours. And of course, along the railroad corridor, you have spontaneous art. So this is the site, and what's really interesting, though, is that in the wetland areas, which are still substantial, there's Phragmites in the back, there's yellow flag iris, and then you have reed canary grass. Those are three, they're on everybody's list of bad actors, horrible invasive species, but you can see they've sorted themselves out across a moisture gradient, and they have restored the functionality of this wetland. And it's really important to separate, the form, which is the species list, from the functionality. So this is actually a very functional landscape from the point of view of ecological services it's providing to the area in which it exists. That's actually ecological thinking. It doesn't really matter that it's not a native species in terms of getting that functionality out of this. This is a derelict site. I suppose with unlimited resources, we could convert it into something resembling what it once was, but that would just be enormously expensive, and it's not clear to me that the site would then function any better than it's currently functioning. And there's the ailanthus, the stately ailanthus growing on the landfill. It's kind of amazing, and there's a lot of plants from the arboretum that have run wild, so this is kind of like a version of the Arnold Arboretum, the wetlands there. But this is my most provocative slide. I don't want to rush this one. So, this is this question of design versus ecology. This is important, stasis versus flux. Design is usually based on some concept, and ecology is not, about stasis. It's all about flux. And of course, you maintain stasis through maintenance activities. And, flux in ecological systems is maintained by competition. Evolution is based on competition. It's a driver. Who's the best adapted? And the conclusions, and this is important, maintenance is about arresting ecological succession in order to preserve design. And my last one, of course, is sustainability is about reducing maintenance in order to promote ecology. That's my definition of sustainability. And whenever I take people out to this site, they're just horrified. When are you going to clean it up? When are you going to fix it? And I say, because that's a basic impulse in landscape architects. They see a site and they want to fix it, And the thing is that I'm not sure this site needs fixing. So the question is, how do you change people's attitudes to a site like this to say, actually, it has value just the way it is? And so working with a professor, Terry Reeb from the University of Buffalo, we created, I know you're not going to believe this, a sound app that you can download from iTunes. The fact that I have created a sound app is unbelievable. And it interprets this site, and as you look, there's the pathway there. Those blue dots represent narratives. They're about 2 to 3 minutes long that tell the story of the history of this site, not in a linear form, but when you're standing in this site, it tells you what happens. But you're not punching in numbers. It's GIS-based, so it comes to you through the map, so that you navigate the site and the stories come to you. If you're listening to a story and you're bored with it, you walk and you come in contact with another story. Or you see there's a blue dot over there, I want to go hear that story. So this is actually something that I think the Presidio is ready for, because it's a way of thinking about these sites that it allows you to talk about their cultural, their social, and their biological history simultaneously, depending on where you're standing. And, you put your headphones on, you're not looking at a computer screen or anything like that. So this is really, this question of interpretation. I try to sort of just apply some of the basics of interpretation to a site like Bussey Brook Meadow. And it's a real challenge, but I really feel as though it's a challenge that we need to think about. So this is, of course, my last slide. and I don't think it needs any explanation. So thank you very much for your attention.